Today, we're going to talk about vertex displacement. Let's go. Alright, so we're in the middle of our series of tutorials on vertex shaders. And today what we're going to talk about is vertex displacement, which means we're using the shaders to move the vertices of the mesh around. So here I have a sphere mesh, and we're going to use some techniques today to animate the vertices or move the vertices around. I have a series of examples here that I'm going to show, and we're going to go through these one at a time. They kind of go from simple to more complex. We're going to start out in Unity's shader graph today, and then we'll switch over to Unreal, and I'll show you how to do the same things in that engine as well. Okay, so the first thing that I want to show you is how to scale an object using the vertex shader. So in Unity, if we come over here to the master stack, you can see I have vertex inputs and I have fragment inputs. Fragment is another word for pixel. So we have a vertex shader here and a pixel shader here. So things that we want to do to affect the vertices will be in this top portion here. The first input port here is position. And what we're going to do today is affect the position of the vertices. And so the first example here is scale. So here I have my object position. This is the position of each of the vertices relative to the object's pivot point. All right, so I'm going to take the object position of each vertex, and I'm going to multiply it by a value. So if I wire this in here to my object space position, now when I slide this slider here, I'm able to scale my object. And basically what this is doing is it's moving each of my vertices away from the center of the object. So if I switch to another shape here, like the capsule, for example, the capsule is just uniformly scaling because each of the vertices here, the vertex positions, are being multiplied by a static value. So there's no differentiation between the behavior of any of these vertices. They're just statically moving further away in a uniform way from the center of the object. All right, so that's a simple way of scaling. We just multiply our object space position by some value. All right, let's take a look at the next example. In this example, we're actually doing the same kind of thing. We're scaling the position of our vertices, but we're scaling in the direction of the normals of the vertex. Just as a reminder, a normal is the direction that the surface or the vertex is pointing or facing. And so let's connect this example up here. We have our object space position, and to it, we're adding our normal vector multiplied by some value. And this value here is the one that we can use as a multiplier to control the magnitude of the effect. So as I slide this slider, what you can see is here I'm getting into negative space, and that's moving things inward, so it's making the object skinnier. And as I get into positive space, now the object is getting fatter. And you can see that it's not a uniform scale like the previous example. It's more like inflating the object like a balloon. Let's see if there's another. Let's see if we use a cube here. Now this one is interesting, and it does a really good job of showing the difference between that uniform scale that we did previously and the scale along normal. So each of these faces has its own independent normal, and as I slide this slider here, you can see that the faces are moving along their own normal, and because the normals are separate, it's actually tearing this object apart. And if we go negative, you can see that it's moving in and making the object skinnier than it was to begin with. So we are adding offsets to our original object space position that is controlled by this multiplier value, and we're moving the vertices in the direction of the normals. All right, let's switch back to our capsule again here. You can see when we use the capsule, it's kind of puffing it up and inflating it like a balloon. All right, let's take a look at our next example. This one is similar to our scale along normal example, except for now we're actually using a texture map. So let's take a look at what's going on here in this shader. So I've got my object space vertex position here. And again, we're adding to it. We've got our normal vector, and we're multiplying that by, here's our texture sample, and here's a value that multiplies the texture sample. So let's set this up to 1. Now you can see what our texture looks like here. And we're multiplying our normal vector by our texture. So the strength of the normal vector offsets is being controlled by this texture here. You can see I've got my cobblestones height map going on here. And as I slide this slider, what you can see is that we're controlling the amplitude or the strength of this texture value here. So I can ramp up the value of the texture, and that value in turn gets multiplied by my normal vector, and then that gets added to my object space position. So I can control here how much displacement I want to apply based on the normal and my bump map or my displacement map. So I'm able to add some nice looking cobblestones to my object and make it look bumpy according to using this texture. Now last week we learned about textures in the Vertex shader, and here is the texture that I'm using, but the reason this works is because I have it set to LOD MIP sample mode. So if I turn on my inspector here and come over here to my node settings, you can see that I have my MIP sampling mode set to LOD, or level of detail. And that's what allows me to sample a texture in the Vertex shader. If I had this set to standard, for example, now I'm getting an error and it won't compile the shader. And that's because it's trying to do operations in this sampler that are only available in the pixel shader. If you want more details on that, go back and watch last week's video. I'll link it in the description down below. So we need to set our texture sampler to MIP sampling mode LOD so that we're able to sample that texture in the Vertex shader. All right, so that's how you do vertex displacement using texture maps. And you're able to do all kinds of really interesting effects using this kind of as a bump map. You can paint where you want your vertices to be pushed outward and where you want them to not be pushed outward. So where it's white, it's pushing the vertices out, and where it's black, it's pushing them out less. All right, that's pretty cool. Let's take a look at the next example here. And now we're starting to get into animation. So I'll just zoom in here. So let's take a look really briefly at what this one is doing. We have our time value coming in here, and we're passing that into a sine wave so that our time value will fluctuate between -1 and 1. And then we're multiplying that with this vector 3 here. So we get 0 in the X and Z channels, and we get a value of 1 in the Y channel. So basically this is filtering out the X and Z channels so that they'll do nothing, so that nothing will be added to our object, to our vertex positions. And then in the Y, we're adding a 1. So what this should do is make our ball move up and down. So I'm going to plug this in. We'll take a look at our preview here now. Now you can see that our ball is moving up and down. We're offsetting our positions 0 on the X, 0 on the Z, but a value of 1 on the Y. And so this sine of time value is getting passed through and added to the Y position of our vertices, but nothing is getting added to the X and Z positions. Now I can do something kind of interesting here if I add an absolute node. If I take my sine wave and add an absolute, it's going to make our ball look like it's bouncing, because instead of going negative, all of the negatives are going to become positives. And so now our ball will appear to hit ground plane here and bounce, because I've turned the negative portions of our sine wave into positive portions. So it gets to 0 and just immediately goes back up again. All right, so that's some simple animation that you can create in the Vertex shader. If you have ambient objects in your scene that need to move around or animate, that's something that you can do very cheaply if you do it in the Vertex shader. This sort of animation is significantly less expensive than trying to do some kind of bones animation or that sort of thing. All right, the last example I have for you today is snow accumulation. So we're going to take a look at that one next. I'll come down here. Let's move our master stack down. Okay, so the first thing that I do with snow accumulation is I create a mask. I'm doing a dot product between 0, 1, 0 and our normal vector. Another way I could do this is just by filtering out and taking the y component of the normal vector. And then I saturate that, and then I raise it to a power of 8. So let's take a look at what this mask looks like just by itself. I'm going to wire this into my base color. And now you can see our result here is that we've got the top of our object here kind of masked out. Everything else is black, but the top of the object is white. And if I set my normal vector here to object space, I'm able to actually rotate the preview around so you can see what that looks like. So right here on the top of our object, you can see that I've got a white mask and everything else is black. And the purpose of this is we want to do snow accumulation, and we want it to look like the snow is settling on the tops of objects. And so I've got this mask here created so that the tops of objects are going to be white and everything else is going to be black. So what do we do with this mask exactly? Well, let's take a look at that. We're going to multiply the mask by our vector 3 value. So it's only affecting our y component. And then we're going to add that to our object position in world space this time. And then we're going to transform from world to object space as a position. So let's plug this into our position node here. And now what you can see is we've got the top of our sphere and it's bumping up. So we're using our mask to select which vertices we want to displace. And then we're telling it we only want to displace the vertices on the y, or up and down. And then we're adding that to our object's position. And so what we could use this for is if we wanted it to look like snow was accumulating on tops of objects, we could animate this value here. Let's set it to 0. So now we just have our object as normal. But then as snow begins to accumulate, you know, here it is accumulating on the top of my object. And it's getting higher and deeper. And it kind of bumps up the top of my object like that as snow. Now, if I wanted to add to this effect, I could take my mask here and bring it down here and add this to our color as well. So if we make our color the same as the mask, now you can see I've got the snow on the top, and it's deforming the object or kind of piling up on the top there. All right, now if I wanted to, I could go into a lot more detail here and, you know, create a snow shader with sparkles and all that sort of thing. But the objective today was just to show how that can be done in the Vertex shader to displace those vertices and make it look like the snow is piling up on top of our object. All right, let's do a quick review, and then we'll jump over to Unreal. So we started out just uniformly scaling the object. Then I showed you how to scale the object along the normals of the object. Then we took a look at texture displacement, and I showed how you can sample a texture and then use that to offset the vertices in the vertex shader. Then we took a look at some animation, and I showed you how you can use a sine wave to oscillate an object back and forth or animate it, and then also add an absolute node to make it bounce. And then we took a look at this last example of snow accumulation, where we can create a mask using a dot product here to just make the vertices on the top of the object rise and fall according to the amount of snow that we want to add. All right, so that is the basics of vertex displacement. Let's jump over to Unreal and I'll show you how to do the same thing there. All right, here we are in Unreal, and in Unreal there are two major differences between the way things work from the way that we just saw how they worked in Unity. The first difference is that we're dealing with world position offset. So instead of adding in the position data here, we already have the position data. We're just giving it how much we would like to offset from that position instead. And it's in world position rather than object space position. And the other difference is that units are in centimeters, as we've talked about before. So the values that we multiply by are hundreds for a meter instead of just 1. So here is our example where we offset based on the normal. So if I plug this into our world position offset, now you can see that our sphere has gotten larger. And if we switch this to a cube, you can see that the faces of the cube, just like we saw in Unity, the faces have separated from each other and have spread out like this. Works the same for the cylinder. The sides of the cylinder are expanded outwards in the direction of the normal, and the top is expanded up, also in the direction of the normal. All right, let's take a look at the next example. This is our texture sample example where we're doing the same thing. We have the world space normals, and we're multiplying those by the texture sample. And this value is a value here that can control how much we want to change things. So I'm going to wire this into our world position offset. And then let's just set this first to sphere. Okay, so you can see that we've got our cobblestones displaced on our sphere, and we're able to control how much displacement we want to apply with this multiplier here. So if I do times 10, you can see that there's less displacement. And if I do like times 30, we get more displacement. Very nice. All right, so you're able to use a texture to displace the vertices. The vertices will bump out where it's white and will stay the same as they were where it's black. All right, let's take a look at our next example. Just kind of scroll down here. And this is our animated example. So we have time. We're doing the sine of time multiplied by 0, 0, and then 100. Obviously, because Unreal is Z up, so we have to put the filter in the Z channel and filter out the X and the Y, instead of in Unity where we're using the Y. All right, so if I pass this into our world position offset, now we get our undulating ball, and if we want to make it bounce, we can add an absolute node to keep those values positive, and now our ball is bouncing off the ground plane. Cool. All right, let's take a look at our final example here. This is our snow mask, just like we looked at in Unity. So if we take a look at the results of our mask, you can see that it's white on the top, and this is the area that's going to be displaced. So we do a dot product between 0, 0, 1 and our vertex normal. And actually, I'm going to do this just slightly more efficiently. I'm going to add a component mask. Instead of doing the dot product of 0, 0, 1, I can get the same result if I just add a component mask like this. There we go. So I'm going to delete this part. So because I know I only want the Y channel, I'm able to just use
or the Z channel rather, I'm able to use a component mask to get the same result without actually having to do a dot product. All right, and then we saturate our result, raise it to a power of 8. This raising to a power controls like how far up the side we want the value to be. If I just set this to 1, you can see that it's going to be all the way down to the bottom. And then if I make this like something like 16, it'll be even sharper, just like right on the very top. And then we multiply the result by 0030, and we pass that into the world position offset. And now you can see I get this little bump here on the top, which is the accumulation of snow on the top of our surface. So you could apply this to all kinds of things, you know, just add this to objects that you want snow to accumulate on top of, and you've got some nice snow accumulation. And then you can control how high it's going to be accumulated with this value here. So if you want a little bit less snow, there you go. All right, so we've taken a look at vertex offsets and vertex displacement in Unreal and Unity. We displaced the vertices along the normals. We displaced the vertices along the normals using a texture sample. We animated the movement of the vertices using time and sine. And then we also created something that could be used to accumulate snow on the tops of surfaces. Next week, we're going to go a little bit further in vertex displacement, and we're going to talk about creating waves for water. That one's going to be pretty cool, so be sure to come back next week and tune in for that. And in the meantime, have a great week, everybody.